You're welcome to this channel, Dynamic Educational Hub, your answer to the very question. This is the first video in this playlist, and in this playlist you'll be learning circle geometry, various theorems in circle geometry, and how you can solve various questions in circle geometry. If you haven't subscribed to my channel, kindly subscribe to my channel. Click on the notification icon to get notified when I release new videos. Alright, thank you, and without further delay, let's start the class. First thing which we will be learning is, within few minutes we'll be learning circle and various parts of circle. What is circle? A circle is a two-dimensional plane shape that its boundary is equidistant from its center, which means a straight line from its center to its boundary is always constant. It is only circle that has this kind of property, in which when you are drawing a straight line from the center to its boundary, you will always get a constant. The value will be constant, it will not change. Unlike every other plane shape, in which when you move from the center to its boundary, you have different length, different distance. And let's look at part of circle. The first part of circle is circumference. Circumference simply means the perimeter or boundary or distance around a circle. And what is arc? Arc is part of circumference. When you pick part of circumference, what you're actually drawing is you are drawing an arc. An arc is also an incomplete circle. A straight line that moves from the center or distance from the center to any part of the circumference in a circle, that distance is known as radius. When you move from the center of a circle to any part of the circumference, a straight line drawn from the center to any part of the circumference is always constant, and the name of that straight line is known as radius. When the plural form of radius is known as radii. A line joining two parts of the circumference passing through the center is known as diameter, and a diameter is a line that divides circle into two equal parts, which is known as semicircle. When a straight line moves from one end of a circle to the other end, and that straight line passes through the center, the name of that line is known as diameter. What is semicircle? Semicircle is half of a circle, and it is area or part of circle bounded by an arc. This is an arc bounded by an arc, and diameter. This is diameter. That part or that area is known as semicircle. A line that joins two parts of the circumference together without passing through the center. So which means a line that divides circle into two unequal parts, which is known as segment. The name of that line is called chord. The area or part that is bounded by, or plane shape that is bounded by an arc and a chord is known as segment. The segment is a shape or part of circle that is bounded by a chord and an arc. Now segments, we are going to have two segments. Since chord is going to divide circle into two unequal parts known as segments, we are going to have the smallest one, which is known as minor segment, and the largest one, which is known as major segment. We also have a sector. A sector is a shape or part of circle that is bounded by two radii and an arc. When we have two radii, the boundary of sector is usually two radii and an arc. So the name of that plane shape or part of circle is known as sector. An external straight line that touches the circumference and moves away, that is, it doesn't divide the circle. When you have an external line and that line is coming and touching your circle without coming across your circle, without cutting your circle, the name of that line is known as tangent. Finally, we have another line, an external line that cuts across the circle, dividing a circle into two unequal parts, or dividing the circle. The name of that line is known as secant. The first theorem which we are going to be learning is a perpendicular line from the center of circle to a chord will bisect a chord into two equal halves. There's one thing about circle theorem. It's not enough to know the theorem, to cram the theorem. This theorem is just a guideline for solving any geometric question, any circle geometric question. And the understanding will give you an insight in which you are going to use to solve any circle geometric question. The first theorem, a perpendicular line from the center of circle to a chord will bisect a chord into two equal halves. Now let's interpret that theorem. When you have a circle and the center of a circle, and you have a chord AB, when a straight line moves from the center to that chord, it's going to be a perpendicular bisector, that is going to divide that chord into two equal parts, two equal halves. So if this chord is 10 centimeters initially, the line from the center is going to divide it into two equal parts. This one will be, this blue line will be 5 centimeters, and this yellow line will also be 5 centimeters. Now you can draw a straight line from the center to join the other end of the chord, the two ends of the chord. You can draw a straight line from the center to join the two ends of the chord together. And when a line runs from the center to any part of the circumference, what is the name of that line? It is known as radius. So which means that from this center to this is going to be the same thing as a line from this center to A, a line from the center to B, because it touches the circumference, and the name of that line is radius. Since it is perpendicular distance, it is perpendicular bisector, the straight line from the center to the chord will make an angle of 90 degrees with the chord. So we have an isosceles triangle. We have two radius. And isosceles triangle, the base angle, the interior angles are the same. So which means we have two right angle triangle coming together to form an isosceles triangle, and which means that this angle will be equivalent to this angle, and this angle will also be equivalent to this angle. So if the angle between the two radii is theta, the angle between this perpendicular line and this radius will be half theta. The same thing with this one, half theta. This one, if this one is theta, this one will also be theta. This one is 90 degrees, this one is 90 degrees, and this length will be equal to this length. This radius is constant, is the same thing. Now with that understanding, we can use trigonometric ratio and Pythagoras theorem. Using trigonometry, we can use it to solve any question. Now let's look at a simple example. Find the length of a chord of a circle of radius 20 centimeters if the angle between the chord and the radius is 40 degrees. We have a question like this. Let's see how to solve it. The first thing you have to do in solving a question like this is you must visualize your question. So you have to draw your circle. The first thing is we draw our circle and we locate the center. This is our circle. According to the question says we have a radius which is 20 centimeters, and radius is a line from the center to the circumference, and then we have a chord. We are asked to find the length of a chord. So you don't know the length, but we are given the angle between the radius and the length of that chord. What is the angle? 40 degrees as shown. And the next thing which you want to do is you want to join the other end of your chord to the center, so which makes it a radius. So this one will also be 20 centimeters. Then what will be this angle? We have an isosceles triangle. This angle will also be 40 degrees. Finally, this angle, what will be it? So let's see how to find that angle. We know that the angle subtended at the center by the radii is going to be 100 degrees. Why is it 100 degrees? This angle, why is it 100 degrees? From the knowledge of trigonometry, sum of interior angles of a triangle. I have a playlist where I explain Euclidean geometry. You can watch videos on it. Now, sum of the interior angles of a triangle is equal to 180 degrees when you add all the interior angles together. So let's say this angle is unknown, theta plus 40 degrees plus 40 degrees is going to give me 180 degrees. So 40 plus 40 is going to be 80, and when you transfer 80 to the other side, you're going to get 180 minus 80. That is what we have here. So theta is going to be 180 minus 80 degrees, which is 100 degrees. So this angle is 100 degrees. Don't forget, we want to find the length of the chord. So this is the length of our chord from here to here, which I've transferred here. So to find the length of that chord, let's call that length x centimeter. Now we can use trigonometry since we want to use trigonometry approach. Using trigonometry approach using sine rule. Let's quickly use sine rule to solve this question. Go and watch my video, the playlist. I have a playlist for trigonometry. You can go ahead and check it out. Now, from the concept or from the rule of sine rule, when you have a triangle like this, the side over sine of the angle that is facing it is always constant. So we want to find this x, we don't know it, so we can say that 20, we know this side, which is 20, divided by sine of the angle that is facing it is equals to, we don't know this side, x over sine of the angle that is facing it, which is 100 degrees. Make x sort of formula by when you cross multiply. Now there are tricks in mathematics, you can compress steps together. Now let me quickly show you this. If you cross multiply, at the end of the day you still have to divide both sides by sine 40. So instead of wasting time, you can simply transfer this sine 100 and bring it here, while leaving this sine 40 as your denominator. So you'll be left with x here. So that is what I've done here. X is equals to 20 sine 100 degree over sine 40. When you press your calculator, the best way to follow my video is you have a note and you have your writing material as well as calculator if it warrants you using it. Now let's continue, which make it 20 multiplied by what is sine 100 is 0.9848, sine 40 is 0.6428. when you punch your calculator, you are going to get 30.64 centimeter. So which means that the length of the chord is going to be 30.64 centimeter. You can see how circle geometry, we solve circle geometry question using trigonometry. So that is the beautiful thing about mathematics. We can still solve the same question using another approach in trigonometry. Let's apply the first theorem. And the first theorem says that the line from the center of a circle to a chord, we divide that chord into two equal parts. So let's draw the line. We draw a perpendicular line from the center, is going to divide this chord into two equal parts. So x will be divided into two, which makes it half x centimeter and half x centimeter using trigonometry ratio. So by choosing half of the triangle shown, you can use secant. So cos 40 degrees equals to adjacent over hypotenuse, which is 1 over 2x over 20. When we solve that, cos 40 degrees will be x over 2 times 20 degrees, which is equals to x over 40. Then making x sort of formula, we have x is equals to 40 cos 40 degrees. When we solve that, we get 40 times is 0.7660, which is also 30.64 centimeter. Now if you decide to extend this line as shown to the circumference and join them together, you have a bigger triangle. So you can still pick that triangle and use it to solve your question. We will still be learning a theorem again that you can apply, and using trigonometry ratio we still get the same question. Now that theorem is the angle subtended by the two ends of a diameter at the circumference is right angle. So we can see that we have a bigger right angle triangle. So if you still apply your trig ratio to solve this question, that diameter becomes the hypotenuse while your chord becomes adjacent. This time around, your chord will now be x. So we now have cos 40 degree is equals to x over 40. Still solving it, we still get 30.64 centimeter. That's the beautiful thing about mathematics. No matter how you solve the question, so far you are using the principle that guide mathematics, you will still arrive at the same answer. Now let's look at another example. Another question, which is what is the diameter of a circle with chord 8 centimeter if the distance between the chord and the center of the circle is 3 centimeter? We have another simple question. Let's see how to solve this. The first thing which you want to do is you want to draw your circle as usual and the center. And according to the question, we are asked to find the radius. So we are given the chord. What is the chord? 8 centimeter. We've drawn the chord. Now the next thing is to join the two ends of that chord, the two ends with the center. And according to the question, we are also told that a line from the center to that chord is 3 centimeter shown. And let's join, and that line is going to be a perpendicular bisector according to our theorem. Now you join the two ends of that chord with the center, which happens to be radius. So we have two radii, and the two radii is going to be the same. So now, since according to the theorem, a straight line from the center to the chord is going to be a perpendicular bisector of that chord, so which means the 8 centimeter will be divided into two equal parts, which is 4 centimeter and 4 centimeter. So we have two right angle triangle that we want to solve, so we can bring one out of it. So I choose to bring this part out. So we are going to have 3 centimeter here, 4 centimeter here, and according to the question, we have to find the diameter, not really radius. And why are we finding radius? There's a relationship between radius and diameter. 2 radii is going to give us 1 diameter. So looking at this, we have a right angle triangle, and our radius obviously is the side that is facing this 90 degree, so which happens to be hypotenuse. We can use Pythagoras theorem. So using Pythagoras theorem, r is the hypotenuse. R square is going to give us 4 square plus 3 square. R square is going to, what is 4 square? 16. What is 3 square? 3 square is 9. So we have 16 plus 9 is equals to 25. What is 16 plus 9? So it's going to give us 25. Since we are looking for r here, so our r automatically is going to be square root of 25. And what is the square root of 25? That is 5. So our r will be 5 centimeter. And we know that diameter is equals to 2 multiplied by radius. So that gives us 2 multiplied by 5 centimeter, which is equals to 10 centimeter. We can see that solving question using that theorem is actually simple. Thank you for watching this video, and if you haven't subscribed to this channel, kindly subscribe to this channel and click on the notification icon to get notified when I release new video like this. Share my video, like my video. See you in the next video. Bye for now.